Hi students, this is Miss Oberly again with part 2 of 10.2 and lesson 10.4. And by the end of this lesson, you will be able to answer these questions. What is a central angle versus an inscribed angle? What is an arc? What are adjacent arcs? And what is arc length? And what do you need to be able to do? Well, find arc lengths and find inscribed angles and their intercepted arcs. So the arc length is blank, while the measure of the arc is blank. So, terms to know. What are adjacent arcs? Adjacent arcs have exactly one point in common. Arc measures of adjacent arcs can be added together. So find the measure of arc LHI in circle M. All right. So since we know that this semicircle would be 180 degrees and this is 90, we know that these two added together form 90 degrees, and LHI then therefore is 90 degrees. All right, what about the measure of arc IJK? So this. Well, here we have a semicircle for this half of the circle. So this whole thing is 180 degrees, and if we subtract 32 from 180 degrees, we can get our final answer of 148 degrees. So what is arc length? Well, the ratio of the arc length to the circumference of the circle, so it's just part of the whole circumference, is equal to the ratio of the degree measure of the arc to 360. So let's keep in mind that this is just part to whole, just as part is to whole. So we can set up a proportion or rewrite it and set up an equation solved for that arc length. Arc length is measured in linear units, and the measure of an arc is in degrees. So when they say the measure of the arc, then we give it in degrees. When they say arc length, we give it in linear units. All right, so find the length of DA, round to the nearest hundredth. So DA is from here to here. So to find that, we could say 40 degrees is to 360, as this arc length, L, is to pi r squared. Oh, I'm sorry, pi times r times 2. That would have been for area. And then we can cross multiply and solve. And in this case, our arc length ends up equaling pi. All right. Oh, and they did ask us to round to the nearest hundredth, so that would be 3.14. All right, find the length of DA, again, round to the nearest hundredth. So DA is this arc right here. And if we know that this is a semicircle, then DA is going to be 180 degrees minus 28. So this is 152. So now I can set up my proportion saying 152 is to 360, as this arc length of DA is to pi 2 pi r, which is 6. And then I can solve my proportion, which gives me an arc length of 15.92. And if you think about it, this looks, about twice as long as that, so it makes sense. I think you've got the hang of this. What is a central angle? Well, a central angle is an angle with a vertex in the center of the circle. Its sides are, so vertex in the center of the circle, its sides are radii. And the sum of the measures of a central angle will always be 360. An inscribed angle, however, is an angle with a vertex on the circle, so not in the center of the circle, and its sides are chords. Inscribed angles are half the measure of their intercepted arc. So whatever this is, if this is x, this will be half of x. All right, so if this is, and if we compare it back to this picture, remember, whatever the arc is, the inscribed angle is half of it. So if we know that this is 81, the arc will be twice as big as 81. So the measure of that arc is going to be 162 degrees. All right. Here we have a central angle again. So if they ask us to find EA, we're going to use the fact that here we have a semicircle. So this is 130, which means this has to be 50 to make up that semicircle of 180 degrees. Here again, I've got an inscribed angle because I can see my angle is formed on the circle. So whatever the arc is, my angle will be half of it. So my arc here would have to be 46 degrees. Here again, I've got central angles to find UPQ. You can see that we're just going to add those together. So UPQ would be 130 degrees. And here I've got an inscribed angle. If we're trying to find the measure of this angle, we're going to have to use the sum of these arcs on the outside, knowing that all of the arcs will add up to 360. So if so far they add up to 220, we know that 360 minus 220 is 140, which means this arc, NQ, is 140. Let me erase that and try that again. So this arc is 140. So half of 140 would mean that this angle would be 70. All right. Here they say find LM if the radius is 5 inches. So would you be able to set up that proportion knowing the radius is 5? And I don't think we'll even solve that because we practiced that earlier. And I think you're getting good at this, so we're just going to skip right on through these. This is where we want to focus now. Here they ask us to find S, angle S. So that's this. And we're going to have to use some bigger picture ideas to do that. So let's pause for a moment. All right, so the fun thing about this is that we know that this angle and this angle will be the same. Oops, I meant to change the color. Let's try that again. This angle will be the same because they share the same intercepted arc. So we could set them equal to each other and solve. We know that 5x plus 4 equals 6x minus 2. And if we move this to this side, we have x, and if we move this to this side, equals 6. And if we know x equals 6, we could plug in 6. 5 times 6 is 30, plus 4 is 34. So this would be 34 degrees. And if we're going to try and find r, we can use the same sort of idea. And let's switch colors again. R, this angle will be the same as this angle, and good news, we already know what that angle is because they share this intercepted arc, which means r will be 32 degrees. So take a look at this. Would you know how to start finding C? Well, C has this intercepted arc, and so does D. So we have two angles that are equal to each other. Could you set up an equation and solve? Does your equation look something like this? 4y plus 7. Good, so we move this over, so we have y equals, move that 3 over, y equals 10. So if I plug in 10, I have 40 plus 7. It is 47 degrees. Same process. If I change to looking at A, we know that A has this intercepted arc, and so does B. So could we set those equal to each other and solve? I think so. So we have 5x equals 7x minus 8. And then negative 2x equals negative 8. So x equals positive 4. So 5 times 4 is 20 degrees. All right. Would you be able to do this?